Okay, let's talk about the fluxes that go into and out of a catchment. If we now draw a catchment here, kind of in a perspective view, so we'll be looking here at the catchment on its side at an angle. This is sort of a cutaway. And you can imagine that there's some stream channel network draining this catchment. The fluxes into and out of the catchment are coming in precipitation, which is commonly denoted with a P, and it has dimensions of length per time. Leaving the catchment is the combined evapotranspiration flux, which also has dimensions of length per time. There's one other flux that's commonly considered to be coming out of the catchment, and that is the stream discharge, which is typically denoted as Q, and commonly has units of volume per time, length cubed per time. And you'll hear people use the word discharge, and this is the same as stream flow. And it's also the same thing as runoff. Although sometimes when we talk about runoff, we're talking about this flux divided by the catchment area. So it's normalized. And there's a point that I want to stress, and that is that even though P and ET are commonly reported in dimensions of length per time, this is a flux, not a velocity. Remember that velocity also has dimensions of length per time. But this is not actually the velocity at which rain is falling down. Instead, what this is it's the amount, the equivalent thickness of water, if you spread it over the landscape, that's arriving in a particular amount of time. So just to give you a little bit of intuition about that, consider some sort of unit area. So a square, that's 1 meter on a side and 1 meter on a side. And then consider a certain thickness of water that's distributed evenly over this square. And let's say that that is about 1 millimeter of thickness. So if someone says the precipitation rate is something like 2 millimeters per hour, that's not the velocity of raindrops falling from the sky. Instead, that's saying that 2 millimeters of equivalent liquid thickness are accumulating over the course of an hour. Just to give you a sense, 1 millimeter over 1 meter squared is equal to 1 liter of liquid water, which is also equal to 1 kilogram in terms of mass. These are just numbers that you should keep in your head as we go along because you'll be using them over and over.